In the previous videos you have already learned a few things about plate tectonics, the structure of the Earth and divergent plate boundaries. Convergent plate boundaries will be explained in this video. If magma solidifies, new oceanic crust is formed, such as with divergent plate boundaries. This means that parts of the crust must also go back into the mantle. This happens at convergent plate boundaries. You have already learned that the newly formed oceanic crust cools as it moves away from the mid-oceanic ridge. The density of the plate increases due to cooling. This makes the plate heavier than the underlying asthenosphere. Therefore, if the oceanic plate collides with another plate, the oceanic plate will dive into the asthenosphere. The other plate can be an oceanic plate. This will then be lighter and must therefore be younger. The other plate can also be a continental plate. You have already learned that a continental plate is always made of lighter material than an oceanic plate, and the continental plate will therefore not dive into the heavier asthenosphere. The diving down of the old heavy oceanic plate is called subduction. On the border between the upper plate and the underlying oceanic plate, a deep area is created in the sea. This deep part in the sea is called a deep sea trench, or simply trench. Along the entire plate boundary where there is subduction, there is a very long trench. Subsequently, the diving plate dives further into the asthenosphere. The older the plate, the heavier and steeper the plate sinks into the asthenosphere. The part of the plate that sinks down pulls the rest of the plate into the asthenosphere. This force is called slap pull. The plate is pulled downwards. This force is the main cause of plate tectonics. The Pacific plate is very old at the time of subduction, which causes the plate to have a high density and diving steeply in the asthenosphere. The slap pull is very strong here, and the Pacific plate has a relatively high speed of around 10 cm per year. On the west side, the Pacific plate dives below the Philippine plate. Due to the age and gravity of the Pacific plate, it dives steeply downwards, creating a trench of 11 km deep. The diving plate also carries a layer of sediment and some water towards the asthenosphere. Once the diving plate arrives in the asthenosphere, it will melt together with the sediment. The molten mass is relatively light and rises to the crust. There the formed magma wants to burst out of the crust, which forms a volcano. Because the magma has a different composition due to the addition of sediment, this is very viscous, which is also called a viscous liquid. The viscous magma flows not far away during an eruption. The volcano is not very wide, but very high. This type of volcano is called a stratovolcano. The magma can't escape from the volcano. Because there are also many gases in the magma, the pressure is increased. At some point there will be a violent eruption due to the increased pressure. This is an explosive eruption. There is a lot of subduction around the Pacific Ocean, so there are also many stratovolcanoes. This area is therefore called the Ring of Fire. There is a ring of stratovolcanoes around the ocean. When a stratovolcano has been emptied, the steep slopes miss the material they could lean on. That is because it has been emitted. This allows them to collapse. Such a collapsed volcano is called a caldera. Sometimes water collects in the caldera, creating a lake, and sometimes the caldera lies in the sea, creating a circular island. The inside of a caldera can be full of water. The Greek island of Santorini is an example of this. The distance from the volcano to the trench is determined by the age of the diving plate. The older the diving plate, the heavier, the steeper the plate dives down. As a result, the plate melts closer to the trench, so that the horizontal distance between the trench and volcanoes is not very large. In short, parallel to the deep sea trench, a row of stratovolcanoes is created. Due to the convergent movement, both plates are compressed a little bit. The upper plate in particular can be compressed, creating hills. In South America, the convergent movement has even created the second highest mountain range of the world. This is just an exception because it usually only causes a hilly landscape. The unique situation of South America will be explained in another video. In this video you have learned what subduction is, how it originates and what consequences subduction has for the height difference on land and in the sea, and how subduction leads to explosive volcanism. In the following video I will elaborate on a convergent movement in which only continental plates are involved.